So with 6.5, we're going to be talking about a lot of the reciprocal functions, and then we're going to finish up with tangent. I'm saving tangent for last because oftentimes students find it to be the most difficult. Tangent and cotangent, where do you put the vertical asymptotes? So we're going to start with secant and cosecant. What makes secant and cosecant so familiar to us is if we know what the sine and cosine graphs look like, we kind of just have to sketch our secant and cosecant graphs on top of them. So we go back to first, what is the secant graph? So secant is the reciprocal of cosine. So cosine, as we saw before, here, I'll just take out our notes again. Here is our cosine graph. It's 0 at pi over 2 and 3 pi over 2. It'd also be 0 at 5 pi over 2, and if we went backwards, it would be at negative pi over 2. Every time that cosine is 0, secant would be undefined. So wherever cosine is equal to 0, then I'm going to put therefore secant is undefined. And that's super important for us because when we had something that was undefined, we got vertical asymptotes. So the properties of our secant graph, we're going to do the same types of things. We're going to have our amplitude, and then we're going to also, instead of our period, because as long as we can graph our cosine graph, then we're good, then we get our vertical asymptotes. So I'm going to walk you through just a simplified version. A, again, is our amplitude. B is our period. And with any reciprocal graph, always start with, for secant or cosine, start with sine or cosine's graph. So secant, start with cosine x. Okay, so our amplitude is 1. Our period is 2 pi. So we are going to, and I'm going to draw this out just a little bit. We're going to go out to our 2 pi. We're going to cut that in half. We get pi. Cut that in half. We get pi over 2. Cut this in half. We get 3 pi over 2. And just for our sake, I'm going to include this negative pi over 2. Our amplitude is 1. Our lower spot is negative 1. And then we're just going to walk around our graph for right now. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1 again. And then for our sake, I'm just going to include negative pi over 2. And what I'm going to do is dashed lines, or dashed curve, I'm going to draw out, because we're not trying to graph cosine here, we're trying to graph secant. So this gives us our basic sketch. So like I said above, wherever cosine is 0, secant is undefined. So we get vertical asymptotes every odd multiple of pi over 2. Because at pi over 2, 3 pi over 2, here would be 5 pi over 2. We're going to get, cosine's going to be 0. So what we do at every odd multiple of pi over 2 is we're going to draw in our vertical asymptotes. So it may look like a bunch of dashed lines on here, but it's going to make sense in just a second. And then these asymptotes keep going, keep repeating. So our secant graph lies on top of our cosine. So what we do here is, in a slightly similar color, these two share a point, and then secant goes up, and it looks just like a parabola. And then from pi over 2 to 3 pi over 2, these share a point, and it just hugs the vertical asymptotes. Same thing right here. These share a point, and it goes back up. So secant, the graph of secant, alternates, and it just lies on top of a cosine graph. So if we flip it over, we're going to try a couple with amplitudes and change of the period. So with example 2, we see that our amplitude, so we always start amplitude, 3. Our period is 2 pi over b, so that's just 2 pi. So that means, for our sake, we're going to start at 0, finish at 2 pi. So just like we did before, first we're going to mess around with amplitude, and then we're going to play around with the period. So just like I did before, we're going to go out to 2 pi, cut that in half to be pi, cut that in half, pi over 2. Halfway between pi and pi over 2 is 3 pi over 2. And then just for our sake, I'm going to take one step back and go negative pi over 2. So our amplitude we said was 3. So let's put 3 on there. So I will do this first one in purple or violet. Cosine of 0 is 3, then 0, then negative 3, then 0, then back up to 3. And here would be 0. So we have our vertical asymptotes. I'm going to put these in purple here. This is our lovely cosine graph, which we're doing to get our basic sketch for our secant. Likewise, it goes down here. So we have vertical asymptotes at negative pi over 2. We have at pi over 2, at 3 pi over 2, at 5 pi over 2, at 7 pi over 2, or negative 3 pi over 2, or negative 5 pi over 2. And then our graph of our secant function just sits right on top and on the bottom of our cosine dashes. So we draw this cosine function in here, which, if we include it as negative pi over 2, kind of looks like a sine function, because cosine is the reciprocal of secant. All right, one more. Hopefully this procedure is starting to click a little more with you guys. So again, we start amplitude. So our amplitude is the absolute value of negative 2. So our amplitude is 2. And I just like to remind everyone that this would be flipped because of the negative sign. Our period is 2 pi over b, which is 2 pi over 1/2. So that means our period ends up being 4 pi. So we are going to start at 0, and we are going to finish at 4 pi. Now once we have all of that, so here's 0, here is 4 pi. If we cut 4 pi in half, we get 2 pi. Cut that in half again, we get pi. And then halfway again here is 3 pi. And again, because this is secant, I'm going to go back an additional pi, because this is our step. We're going pi, 2 pi, 3 pi, 4 pi. So our step is pi, so I go back a pi. Our high value would be 2, and our low value would be negative 2. All right, so let's see. We're going to do orange. So if I plug in 0, I should get 2, but because it's flipped, we'll be at negative 2. Then if I plug in pi, we get 0. If I plug in 2 pi, we get positive 2. If I plug in 3 pi, we are back to 0. And if I plug in 4 pi, we're back to negative 2. And again, just for our sake, to make our life a little easier, we're going to do negative pi. So we draw in our dashes. And if I cover this up, there's our cosine 1 revolution graph. So now we see that our vertical asymptotes happen at every multiple of pi. So at negative pi, at 2 pi, at pi, at 3 pi, the next one would be at 5 pi. So just so we write it out, our vertical asymptotes happen at x equals odd multiples of pi. So that's the verbal way of saying it. I could also say x equals 2k minus 1 times pi. K is integer. So this is the fancy math way of writing that vertical equation. If you can just explain to me in words, I will be perfectly happy with you in doing that. The last thing that we have to do is draw in our secant. All right, so this is secant. If we flip it over, we're going to talk about cosecant, and you'll notice that it's very, very similar. So just like with secant, cosecant is the reciprocal of sine. So cosecant is equal to 1 over the sine value. So everything that we were doing for secant graphs applies to cosecant. What I do want to highlight is our vertical asymptotes happen wherever sine is 0. Or put it mathematically, since sine is 0 every pi, we say at multiples of pi. Or sometimes you'll see x equals k times pi, where k is element of the integers. And just remember, that bold z just means integers. So I'm trying to avoid as best I can writing these fancy math lingo that we've gone over plenty before. So if you just remember that cosecant happens at the multiples of pi, and secant happens at odd multiples of pi over 2. Okay, so with cosecant, start with your sine graph. So our amplitude is 1, our period is 2 pi. So draw this out just a little bit. That means our start is going to be at 0, our finish is going to be at 2 pi. So this is 0 right here. We'll go out 2 pi units, cut that in half, we get pi, cut that in half again, we get pi over 2, cut this in half, we get 3 pi over 2. Amplitude is 1, so we go up and down -1. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of 2 pi is 0. So with our lighter color, we're going to draw in our dashed sine curve just so we see that we get here. And since sine is undefined, or sorry, sine is 0 at 0, pi, 2 pi. The next one would be 3 pi, 4 pi. Cosecant is going to have vertical asymptotes where sine is 0. So with our blue, our cosecant just sits right on top of our sine curve. And that's how we graph cosecant. So, like all, we have one example that's a mixture of amplitude and period. So, our amplitude here is 4. Our period is 2 pi over b, which is 2 pi over 2, or pi. That means our starting spot is going to be 0. Our finish will be at pi. So now we can draw in our graph. So we're going to go out pi units, cut that in half, we get pi over 2. Cut that in half again, pi over 4. Halfway between pi over 2 and pi is 3 pi over 4. Our amplitude is 1, 2, 3, 4. Down, 1, 2, 3, 4. So we go 0, and then up at pi over 4, 0 at pi over 2, down negative 3 pi, or down to negative 4, and back to 0. So in orange, we're going to sketch in our sine graph, and we have vertical asymptotes at every multiple of, right here, our halfway point, pi over 2. So let's draw those in. So we have our 1 at 0, we have our 1 at pi over 2, we have 1 at pi, next one would be at 3 pi over 2, then 2 pi, then 5 pi over 2. It's just happening twice as fast. So then our graph, sorry if these cross over just a little bit, it's just going to sit right on top and on the bottom of our sine graph. And again, these repeat, so we have one down here, one up here, one up here. Okay, so that's secant and cosecant graphs. If you can graph sine and cosine, you should be good with these.